Okay, buddy, this is the encyclopedia, and I know you like to learn about this stuff. Earth is your favorite planet, so I'm going to read about Earth. Compared to the other planets in our solar system, Earth is astonishingly active. Its surface is continually recycled, and its atmosphere sustains a stunning variety of life. Earth is the largest of four rocky or terrestrial planets, while radically different from one another. Mercury, Venus, Earth, and Mars are easily distinguished from the gas giant planets of Jupiter, Saturn, Uranus, and Neptune by their size, density, and chemical composition. Terrestrial planets are composed mainly of dense rocky materials such as basalt and metals such as iron. Gas giant planets are more like the Sun in composition. They have enormous atmospheres, mainly of hydrogen and helium, wrapped around rocky centers. The terrestrial planets have far greater densities than the gas planets, but are low in mass. Earth has only 1/15 the mass of the smallest gas giant, Uranus. Earth's birth, some 4.6 billion years ago, the solar system formed out of a cold cloud of interstellar gas and dust. The densest part of the cloud coalesced into the proto-sun, while the remainder flattened into a far-flung disk called the solar nebula. Here are cross-sections of Earth and Jupiter. They're not to scale. They show the contrasting structures of terrestrial and gas giant planets. A female figure has often symbolized Earth as it has as in this 2000 BC bas relief of Simeon, whatever Earth goddess. Wait, let me go back here. So particles in the nebula collided and struck, gradually excreting to form the planets. Earth's characteristic properties were instilled at birth. It formed hot and was heated further by the decay of radioactive elements in its interior. The heat turned Earth molten and caused the heaviest metals, such as nickel and iron, to sink to the center, while lighter elements, such as silicon, rose to the surface. Even the impact of the small planet that probably led to the birth of the moon did not disrupt the arrangement for very long. Peeling the layers, although Earth's interior is nearby in astronomical terms, its center lies less than 4,000 miles below our feet. It remains frustratingly out of reach. To look inside our planet, scientists rely on earthquakes, studying how seismic waves rebound and refract as they travel through the interior. In simple terms, the picture they give the Earth resembles an onion made of rock. At the center is the core, which extends upward to the point of 1,800 miles below the surface. The core is about 90% nickel and iron and has two parts. The inner core is more than hot enough to be liquid, about 9,000 degrees Fahrenheit, but it is kept solid by the enormous pressure, which is nearly 4 million times that at the surface. In the outer core, the pressure is lower, and temperatures are about 900 degrees Fahrenheit cooler, and the iron remains liquid. This liquid nickel iron flows in turbulent currents that give rise to the Earth's magnetic field. The field reaches up through the planet, past the surface, where it controls our magnetic compass, and out into space, where it affects the flow of charged solar particles flowing past Earth. Above the core is a layer called the mantle, composed of high-density iron and magnesium silicate minerals. While not liquid like the outer core, the rocks of the mantle are hot enough to flow, and the energy that they carry powers all the tectonic activity we see on the surface. The rocks that make up the Earth's surface form a thin but distinct layer called the crust. We live on the continental type of crust. It is made of lightweight granite and carbonate rocks and between 20 to 40 miles thick. A second, what does it say? Hold on. A second kind of crust, oceanic, is made of heavier, denser basalt. It is only 3 miles thick. Most oceanic crust is covered by miles of seawater, so until recently, geologists mainly studied the continental crust. However, there are a few places, such as Iceland, where oceanic crust is exposed. And here are the different types of rocks.